This is a follow-up to a study I did with Professor Yingku Li from the University of Tennessee and his colleague Jibin Zhao at Hebei Normal University in China. And we're trying to get some general suggestions about how you define study areas on the basis of analysis of large population of glacial cirques. Now, I think you know that glacial cirques are concave landforms formed at the sources of mountain glaciers. They are doubly concave, they're open downstream, but bounded upstream by the convex crest of a steep headwall. And the headwall should be arcuate in plan around the gently sloping floor. We study cirques partly of their own interest and their scenic value, but also to relate to former snow lines of former small glaciers. So the spatial variation tells us quite a lot about former climates, mainly the precipitation, the temperature, the solar radiation, and the wind direction. So we're looking here mainly at spatial trends from these large data sets. I think you know what cirques look like. Here are some from the British Isles and from Romania, but of course you do have very many cirques throughout the Taurus Mountains in Turkey, the Black Sea Mountains, and the mountains in eastern Turkey. And you may have seen a poster by several of our colleagues finding cirques in previously unrecognized areas just north of Antalya in the western Taurus. But I'm going to talk today mainly about the Himalayas and the Tian Shan. And this is the area on the Tibet-India-Nepal border that we have analysed, which has a large number of cirques, and we've measured the empty cirques. It's a bit more complicated dealing with cirques when there's a large glacier filling the cirque. So the blue polygons on this map are empty cirques. You can see the total study area, and you see that we can subdivide it into the western and eastern regions, and subdivide using valleys and low passes into separate mountain blocks, each of which still has a sufficient number of cirques to provide some statistical results. So the main variation of the cirque floor altitudes in the central Himalayas is the northward rise due to precipitation, snowfall, coming from the south. There's also some variation between west and east, and we analysed this combination by two control regressions predicting cirque floor altitude from the eastern coordinate and the northern coordinate. So the coefficients on each of those coordinates are shown by the second and third columns here. How strong is the eastward trend? How strong is the northward part of the trend? And then we can combine these, of course, to say exactly in which direction the trend is going. Now, here we have 455 empty cirques, and the floors rise at 14 meters per kilometer towards the northeast, towards 020, combining the eastward and the northward. In other words, the northward trend, as you saw from the coefficients, the northward part of the trend is stronger than the eastward part. This we can relate to modern precipitation, which declines to the northeast, so slightly different direction, about 18 degrees differently. I won't go into the aspect of these cirques because the mountains are very high and we have cirques facing north, south, east and west. But the situation is different in some other areas. Moving on quickly to the Tian Shan, the eastern part of the Tian Shan has this west-northwest, east-southeast trend, and so we divided it by these double lines into west, central and east regions, and by single lines into smaller sub-regions. Now, I expected the Cirque floor altitudes to rise eastwards because I thought the precipitation comes mainly from the west in the northern Tian Shan. But this tendency is found only, if you look at the top left-hand diagram, it's found only in the western third of the study area. The larger tendency, as you can see in the bottom diagrams, especially the central and the east regions, the larger tendency is the floors rise towards the south. So again, running these multiple regressions, we see that the southward rises are quite steep for small areas, although perhaps a sample of 24 for one of the areas is rather too small. It's interesting that the trends vary quite considerably between the different sub-areas and even between the major divisions, even though they are adjacent to each other and suffering fairly similar climates. If you look at the way in which cirques face, the aspect in which they are open, we often see a strong asymmetry because of shade differences and because of wind and other effects. Now, in the eastern Tian Shan, all of the areas I've shown here show a north or north-northeast tendency. In other words, the dominant effect on cirque aspect here is shade, possibly with a little bit of a morning-afternoon difference, giving a slight eastward displacement. So you see all of those vector mean directions are somewhat east of north. To conclude about the eastern Tian Shan, the 2,677 modern glaciers in this region, the modern small glaciers, have a mean very close to north, a mean of 355 degrees, and the strength, the vector strength of 53%, meaning a very strong asymmetry, a very strong tendency to face northwards, suggesting that the dominance of shade is considerable and is greater when we look at the modern glaciers than when we look at the cirques. So the dominance of shade is greater today than it was during perhaps the last glacial maximum when cirque formation was still active. Of course, the cirque formation will have gone through several different cycles of glaciation. If we assume that the glaciers are sourced in the cirques, so there are more cirques at the heads of glaciers, the combination of glaciers and empty cirques together show an overwhelmingly northward tendency for the total cirque population. As a third example of the difference in results we get when we subdivide differently, I'll take my old hunting ground of the English Lake District and 157, or perhaps in this analysis 155, glacial cirques. The green lines on this map divide the mountains into small mountain blocks or ranges. And these are named on the next slide. Looking at the vector mean and the vector strength of the Cirque head wall aspects, we can see it is mainly around northeast for the whole of the Lake District. It is 49 degrees, so very close to northeast. But between the different mountain ranges, the different blocks, quite small areas within this massif, we have a variation between northward and eastward. And in this table I have ranked them in order from the most northward, which is in the western mountain block, and the most eastward, which is in the central and Coniston mountain blocks. Now, I think these results show a certain consistency, but they do show that if you look at small areas, the topographic effect becomes quite important, as well as the climatic effect. I've mainly been looking at the climatic effect, and my reasoning is that if you look at a quite large area, the topographic differences, unless the mountains are very strongly lineated, the topographic effects cancel each other out, and you have a chance for glaciers to face north, south, east or west. So if they do face in a certain direction, then that is probably of climatic origin. However, if you look at the small area, then it's affected, of course, by the direction of the ridges. So that in this case, the western region has east-west ridges with few east-facing sites for glacier formation, and hence north-facing cirques are favoured. The central region and Coniston and eastern regions are elongated north-south, and so winds shifting snow from the west side to the east side favour east-facing glacier development rather than north-facing. And the ones in the middle have both north-south and east-west ridges, and so they come closer to the overall northeast tendency, which shows a combination of shade effects and west wind effects. Right, and on the next diagram you can see the what I call vector diagrams for each of these subdivisions. Perhaps you can see with a very small arrow at the end of the longer straight line. That is the vector resultant that gives you the average direction, and its relative length gives you the strength of that tendency. So again, you see at the top, more or less northward facing, at the bottom, more east facing cirques. So I would say that the aspect of the cirques in the Lake District provide meaningful results even for small regions, but the smallest regions are more strongly affected by topography as well as climate. In terms of the Lake District, I haven't mentioned the trends because these are very weak. It's a very small region, and you probably need a larger region to define the trends better. If you look at the correlations between the morphometric parameters like the gradient and the shape and the altitude and so on, for all 158 cirques in the original data set here, correlations of stronger than 0.16 are significant at the 0.05 level. And of course, any correlations weaker than that are not going to be of real interest. If you have a subdivision with 33 cirques, correlations need to be over 0.35 before they are significant. And for ranges with only, I think one range with only 10 cirques, you have to have over 0.64. So you're not going to get many reliable correlations from such a small division. So I'm going to conclude with a few pontifications, which I think may be obvious. You may know these already. It is quite important to analyze your data at multiple scales, and by that I mean in this case looking at a large region and subdivisions of that region. And this shows that results can vary considerably, even between adjacent areas. And so that gives you a test of the robustness of any conclusions you want to draw from the statistical results. So it's very useful to study contiguous study areas. It's important, of course, to define the study area in a meaningful way, and define the limits precisely, in my case here, using valleys to separate mountain ranges. And it's also important to have fairly compact areas that can have something in common in terms of their climate. Geology tends to be a bit more complicated, and I'm not going to talk about that today. The study areas need to be not too small, because they have to include sufficient features to give significant results, as we saw in my final example, and they should not be too large, or different trends may be averaged. So thank you very much for your attention, and these are my main references.